Welcome, everybody. I'm David Kemp, your host of Highway to Health podcast series, where we've been blessed to speak with and learn from some of the most innovative and disruptive leaders in the healthcare industry. And over the last few years, we've all experienced how important early detection, accuracy of diagnosis, and then the personalization of care can be for our patients and our healthcare community. With so much innovation in this space, patients and providers have more power. They have more choices than ever before. And to learn more about this space, we've invited Chief Technical Officer Sivan Bercovici and Medical Director Dr. Sarah Park from Karius onto the show today. Well, Dr. Park, Sivan, thank you so much for joining us, and we're happy to have you on Highway to Health. You know, we'll get into the science and we'll get into the industry talk here in a minute, but I open up almost every podcast with this question, and I've always found the answers interesting and humanizing. Dr. Park, we'll start with you. You know, mental health, physical health is so important these days, and I always like to hear what some of our leaders in the industry do outside of work to maintain, you know, their mental acuity, their sharpness, stay rested, or even something physical that you like to do to keep your body in shape and healthy and ready to come to work and perform for everybody at the organization. What are some of the habits that you've picked up, Dr. Park, over the last few years to maintain that mental and physical health?
Well, I've always been a big runner, actually. So I'm into distance running. Although with my kids, it's been a little bit abbreviated. that can't go quite on the long distance because they're still young that I'd like to. But yeah, long time distance runner doing marathons and stuff. And I just find running is a sport that, you know, you can do anywhere. Just need a good pair of shoes and just go out the door. And it's actually really cool. And for me, especially when traveling, it's a great way to see where you are on foot, you know, and sort of really get to see things up close and personal and get away from like office setting and whatever. And just so many pluses, you know, mentally and physically from running. So that's what I do.
If there's been a trend on this podcast when I've asked that question, it's been running, long distance running. And then the second one that I've heard a lot of is mixed martial arts, actually, which
oh wow.
Are two things that I haven't done a lot of. And I'm trying to work into, you know, what I do, because if successful people are doing it, then maybe it's worth trying out. Sivan, what about you? What do you do? What are some of the habits you've built up to maintain that physical and mental health?
Yeah, thanks, David, for this question. Such a wonderful way to kick us off. You know, I think that many of us have experienced this pandemic in different ways, but for many, it actually translated into working from home, which was also my case for the last few years, splitting my time between home and here at the office. So what I've decided to do early on is to actually wrap up my day with a virtual commute, to actually leave the house as I walk out of that last meeting of the day, and then do a little walk in the neighborhood, coming back home, and then leaving my phone aside and leaving, you know, the key elements that are going on at work, so I can focus on my family. Everyone had the commute back home and that switch from work to life, but then the pandemic kind of got us back into a situation where everything is blurry. So reintroducing this notion of a kind of a virtual commute, just walk out and walk back in, to do that switch was very helpful for me.
I love that. That's one I haven't heard before, but when I'm coming into the office, I have about an hour drive to and from the office. And I find it a little selfish, but I kind of enjoy it. On the way into work, I get to, you know, listen to my favorite podcast and prepare for the day mentally. And then on the way home, I get to leave everything in the rearview mirror a little bit, so that when I'm at home, I'm present. For those that work from home, they don't always get that. I love that idea. I'm going to have to use that and share it with my wife too, who might need a break after the end of the day before the kids get home from school. I appreciate those answers. And you touched on something, Sivan, that I think we want to dig into a little bit more. And, you know, it's how the pandemic has affected all of us. And, you know, on the podcast, episode after episode, we've focused on how we're all in this together. We're on this open road journey to improve patient access, patient experience, and then of course the overall outcomes or the overall health of our population and our communities. And with the pandemic, especially with COVID, and then also with some of the things that you've seen with some of the recent diseases like monkeypox, early detection and treatment has been key to the success and the further health of our population, our community. And so diagnostics has played a big role in this. And I know those of you at Karius have done a great job and have played a huge role in some of this. What are some of the traditional challenges? We'll get into Karius here in a minute, but just in the field in general, Sivan, this is for you. What are some of the traditional challenges that you've seen in the diagnostics field in terms of early detection and in general with the immunocompromised?
Yeah, I'll start with a very high level answer to that, but then I'll really appreciate Sarah's medical view in the same context, because I think that the two worlds are complementing each other. When I've been looking at the diagnostic space for more than a decade now, including in the infectious disease space, in the cancer space, in the hereditary disease space, the majority of tools that existed really revolved around the idea of having a good hunch on what's behind the symptoms, what's behind the disease. And as a function of that, the doctor will know how to hold the right test and then try to look at the data coming out from that test to integrate that in the clinical decision-making, the next step and the next step. Now, we have all heard about a very large number of diagnostic odysseys where it's unclear and empiric treatment is being used until you get to the right answer. And we've seen that going on in hereditary diseases with these really long odysseys. We've seen that going on in cancer where chemo is applied first before targeted therapies. And it so happens that that seems to be also the case here with infectious disease diagnostics, where the conventional tools that exist out there, before we even talk about what Karius is doing, the things that are being applied are technologies that have been with us for many, many years. The blood culture, the PCR test. We all now have at-home experience with some of these infectious disease tests. So whenever you have a clear idea of what's potentially behind the disease, you have a very basic test that allows you to wrap your head around whether or not you were correct and then the next action. But in many cases, it's really hard to tell what the true story is. And I think, Sarah, maybe this will be a good part for you to provide some additional clinical context.
Yeah, I mean, Sivan's hitting it on the head. I mean, the big frustration as a clinician when you're confronted with your patient, I mean, obviously you want to get at the answer quickly to be able to treat that patient effectively and head off any problems down the road. And the sooner you can do it, the better, especially because if time's going on and the illness gets worse, you can imagine then you have 10 more things you have to deal with for the patient, and potentially a patient could, really end up with some really serious disease and die. And I think the immunocompromised population is a great example of why diagnostics are so important. Good infectious disease diagnostics are important for everyone, but I think the immunocompromised population themselves pose the biggest challenge because they're wide open to anything and everything out there. And it's not just one infection that they could have. They could have 5, 10, it literally, because they have no immune system, or their immune system is, somehow severely affected. So that just makes the job for a clinician that much tougher. You're asking your clinician all kinds of questions. I mean, asking the patient all kinds of questions to understand, what are their exposures that could have led to XYZ infections? What have they been taking their medications appropriately? You're doing basic laboratories to understand where is their immune status is, right now. And then you're confronted with someone who has no immune status. And it's like, well, all bets are off. So then what diagnostics do you do? And our diagnostics, as Sivan's mentioned, our existing diagnostics and available ones are rather old. They've been around for a while, and they're also very targeted, so as a clinician, you really have to think about, which tests do I order? We don't want to, with insurers now, you have to be careful what you do or don't order, because your insurer might say, well, no, I don't think this is called for. But you as a clinician feel very strongly it needs to be done. So you're ordering 10, 20 different tests, infectious disease diagnostic tests. And this is where it gets very challenging. And this is where a test like the Karius test could be very useful, in conjunction with your other tests to be able to add, potentially the answer to the question you're asking, which is what is causing the problem for my patient.
Sivan, tell us a little bit about how Karius is leveraging machine learning and artificial intelligence to speed up that detection and do it in a more accurate fashion compared to maybe some traditional methods.
Yeah. So just to bring the audience into the world in which Karius operates, I'll just briefly mention how this company came about. It was about 8 years ago back at Stanford when we were studying transplant patients. And we were looking at the cell-free DNA floating in these patients' blood. And the majority of the cell-free DNA that is just detached from the cells, when cell die, they shed their DNA into the bloodstream. The majority of that is human by origin. And we've seen many companies leverage that new analyte, cell-free DNA, to perform early detection of cancer. We've seen Grail and Guardant. We've seen non-invasive prenatal testing with companies like Natera and others. We realized at Stanford that besides that big compartment of human cell-free DNA, there's also microbial cell-free DNA. Now that has nothing to do necessarily with bacteremia or viremia. There's cell-free DNA coming from microbes regardless of where they are in the body, regardless of whether or not they're pathogens or commensals. When these microbes die, they shed their DNA into the bloodstream where someone can harvest that signal and analyze that. So once we made that discovery, we spun this company out of Stanford, and it took us about 2 years to develop two core technologies, the chemistry and then the machine learning. Now, the chemistry worked really, really, really hard to capture as many molecules as possible so that we don't leave any microbe behind. And that we worked really hard to make sure that it works at scale. So under the assumption that you're going to actually apply this technology repeatedly and at scale, we had to do a lot of automation. But then machine learning had to kick in to actually make sense of all that data. Now, computer science has been around for a while, and what I like, the reason why I'm so attracted to that field is that software and data and math drove a lot of complexity down in the last couple of decades. And we've seen that industry after industry, software came in, data followed, math combined everything together to bring really complex problems to something that we can actually approach. And we've seen the same thing happening, of course, in cancer and other hereditary disease diagnostics. And now it's happening again here with microbial cell-free DNA. So where does machine learning play a role here? And what kind of major role does it play? Because we didn't need it for the PCR test. You just counted a few things and you had a simple threshold and either you're positive or negative. All of a sudden, we have a microscope that can see anything with DNA. So it turns out that you and me and Sarah here on the call, we all have microbes. And we have mixtures of microbes. And what's making it very hard is that this mixture of microbes or cell-free DNA coming from these microbes, they can be similar to one another. They can be similar to other things. We're going to talk maybe later on here on monkeypox. What about cowpox or chickenpox? What's the similarity, the genetic similarity between those? And can we differentiate between them? So now you and me and Sarah, we all have these mixtures of microbes. And machine learning had to kick in to deconvolute that complex signal, to tell you exactly which microbes you have and what's the concentration of each one of these microbes. Unless you apply these really sophisticated algorithms, and I'd be more than happy to tell you about any one of those, unless you apply these algorithms, you end up with a pile of pieces of DNA that are impenetrable for any physician, even for Sarah here, which is among the best ones that I know. So that's where machine learning plays a role.
And I love how you explain that, Sivan, because this solution depends on the intersection of what you just talked about, the chemistry and the technology. Dr. Park, you talked a little bit about, how you're almost casting a wider net, right? Instead of ordering 15, 20 different labs. Can you tell us a little bit more about how, Karius and the solution there is maybe even, just expound on it, where instead of having to do a bunch of different labs with later detection, now you're starting to cast a wider net earlier in the process. And I think that'll shed some more light on what Sivan was just talking about with the machine learning and being able to to break it down from there.
Yeah, I think it's really important to understand that the Karius test has this huge potential, but just like, you talk about intersection of chemistry and such, there's also an intersection with the clinical context, the patient themselves, what's going on with the patient. So the Karius test definitely, it's like any diagnostic test, actually. It's not even just a Karius test. The earlier you use it in the appropriate circumstances, the better you're going to, the better the result's going to be, the more meaningful that result will be. But that result also still needs to be interpreted in the context of the patient themselves, right? And so we have this amazing technology that it can cast, as you say, a broad net, and we can potentially come back with, a single detection of a microbe, or potentially we could be detecting several. Some of them are infecting, and some of them may be what we call commensals. They're occurring because, particularly the immunocompromised, they might have compromise of their gut systems. And so we normally have bacteria in our guts, and that could be spilling over. We could be detecting that. But, in the clinician, this is where you don't just order the test. The clinician involved is getting information, knows their patient really well, looks at the test result, and then interprets that test result based on their patient in terms of, yeah, that makes sense for what I was thinking, or, oh my gosh, this was out of left field. I had no idea. That's the potential of Karius, especially that latter one, right? Of something where the clinician had no idea that it could be a potential, and yet we detected it. And then they think about it and they go, that totally makes sense, but I just hadn't thought of that, because there's so many thousands of pathogens out there that could be infecting us, and especially an immunocompromised person. So this is the potential of the Karius test, and so exciting, right? To be able to use something like this in conjunction with the other basic laboratories and other infectious disease diagnostics, and then getting a better picture. It's like looking at pieces of a puzzle, and some of the pieces are together, and without the Karius test, we're still missing a huge part of the picture. And hopefully what the Karius test does, especially if you bring it in sooner, is fill in more of that picture and make that picture more meaningful, so that the clinician can actually use the appropriate antimicrobials, know how to manage the patient better, potentially have that chance to save the patient, so that is the great potential that I think the Karius test provides.
Just from some of the patient stories that I've seen on your website and other channels of these patients that, it was almost a mystery as to why they were experiencing certain symptoms. The initial diagnosis or, feedback from their doctor based on their history led them to some options and some diagnosis that maybe weren't the most accurate, because you're just working off the information that you have at your fingertips. And sometimes you're making, the best hypothesis you can make. But in each one of the stories on the Karius test, it just helped shine a light on all of the data available, which then helped provide more accurate, personalized treatment for that patient. And personalized care now is so important because of everything that we've been through. We know different people respond differently to different diseases and infections and even treatments. And so how, Dr. Park, you or Sivan, either one of you, I'd like to get your feedback on just the personalization of care and how important it is to be looking at the data and the symptoms of that person and treating that individual instead of, just working off of, generalizations, and how we've seen that play out over the last few years, especially with how different people are affected with COVID and monkeypox and these other things. Talk a little bit about the personalization of care over the last few years.
Yeah, I think it's so important. It's, as I mentioned earlier, it's, a test result by itself is not really meaningful. It's positive, negative, detect this or that. What does that really mean until you put it in the context of the patient? Where are they in their clinical status? What medications are they currently on? what have they been traveling recently or been completely, during the shutdown, completely shut in? What are their potential exposures? All these things make a difference in terms of how then that test result is interpreted. So you can't, the same microbe that is detected in patient A is not going to have the same impact as that same microbe being detected in patient B. If the clinical status is completely different, maybe in patient A, we detect something and that patient A is completely otherwise healthy, but has some obvious health issues, but for which the test was called for. But otherwise, this bug could be considered, well, maybe not the primary cause of infection. Whereas in patient B, maybe they're severely immunocompromised, and this bug that normally might be something that could be found in your normal flora, so to speak, is now considered a serious pathogen. I mean, kind of making things up, but just trying to show, the stark differences that, a patient's history, circumstances can contribute. And towards your question of personalizing, that's where it's so important to have that context and not just to say, dismiss these as it's just a test result and just, what does the test result say? You have to really consider what's going on with the patient to be able to really have meaning for that result.
Couldn't agree more. Sivan?
Yeah, maybe just to add a little bit to Sarah's notes here. When I think about personalized medicine or precision medicine at large, we speak about the right drug for the right patient at the right time. Now, you bring that element into infectious disease diagnostics, and here within Karius, we talk about additional things beyond right drug, right patient, right time. What about the right dose? Each one of us might need a different dose based on where they are. What about the cocktail of things that this patient is already taking? We all know that if you take certain antimicrobials, that may have additional effect, and you may need to counter those effects. Many of our patients are transplant patients. How do you balance all these other things? So we take precision medicine one step forward beyond right person, right drug at the right time and into these additional questions. Earlier this year, we added a major enhancement for the Karius test that focused on antimicrobial resistance detection. So the core Karius technology focused on detecting microbes, estimating their quantities, but then the physician was faced with this dilemma. Let's say you have a Staph aureus case. Is this a methicillin-resistant Staph aureus or methicillin-sensitive? Which door should we open? So earlier this year, we released an expansion of the Karius technology that included for the first time a liquid biopsy version of our test that also determines whether or not it's MRSA, methicillin-resistant Staph aureus, or MSSA, methicillin-sensitive Staph aureus. So now that the doctors are opening the reports, they can get this additional information that is personalized for that patient. Now, we expand that technology to include additional targets because it's just not one microbe that has antimicrobial resistance. We all heard about all these horror stories about patients that are just not responding. So naturally, our technology needs to evolve to include those elements as well. Now, a second element, just tapping into something that Sarah just said, is this quantification of the microbes that we see in a person's blood or plasma in our case. It turns out that in some cases, we see this correlation between quantities and how severely ill the patient is. And the more ill the patients become, the concentration keeps going up. But once you apply the right drug, a drug that is effective, for that case, we definitely see cases in which we see these numbers going down, the concentration going down, all the way to these extreme interventional procedures where you remove the infected tissue and the signal goes down to zero. So the quantitative nature of this technology allows us to think about how the course of treatment is going. Is it going well, or should we change something? Now, look, David, at the end of the day, the first thing that goes through the patient mind is, when can I go back home? Right? They just want to get out of there. They want to go out of the hospital. We all know that. Many of us experienced similar situations before, either for us or our family members. And this technology gives another dimension to this dialogue between physician, patient, and disease to figure out what is the right time to allow that patient to go home. Maybe there are parts of the treatment that can be achieved outside of the hospital. I think these are all the different dimensions that Karius and others in our field are now battling when we consider where this technology can go in the investment of care.
Well, let's even take a step back in terms of the treatment, obviously, you touched on. But even earlier in the process, during the diagnostics phase, instead of an invasive biopsy, Karius provides.
Yeah, it's off of a blood test. I mean,
Yeah.
it's crazy amazing. One of my clinical colleagues actually said to me, she was like, "You guys are doing Star Trek medicine." I said, "Well, maybe not quite Star Trek medicine. We don't have the tricorder that you just wave. That would be truly amazing." But it's amazing. I mean, if you had asked me, 10 years ago, if this was something that was possible, I'd look at you and go, that really would be Star Trek medicine. It would be amazing. But, I would have been very skeptical. And to be, leap 10 years forward, and here we are, and we're actually doing it. It is amazing. We're still learning a lot about it. And there's probably even more potential that we haven't yet uncovered, to be honest. But, we're still at sort of the baby step phase, I think, in some ways, in sort of clinical interpretation and understanding of it. Sivan and folks on the analytics part, they're going leaps and bounds and making such great advances. But the clinical side, I think we're still trying to figure out, what does it really mean when they're detecting? It's kind of like, when CT scans, first came out, and even now, right? They're so exquisitely sensitive that they pick up so many minutia, and the radiologists were all like, we're not sure. I mean, how many of us clinicians have seen a report and said, could be this cannot exclude this. It's a whole laundry list and must be correlated, clinically correlated. Well, in a way, this is not unlike that. We have a test that's exquisitely sensitive. And amazingly so, it has opens up so much potential, but does need to have that clinical correlation. And we're still learning what does that mean in that context? This patient versus that patient. So yeah, it's pretty cool stuff, and we're trying to figure out where working with clinicians, colleagues out there, and learning ourselves. Where does Karius test provide the most optimal care, in terms of the diagnostic journey for a patient. And it probably is very individual to each patient when it's comes down to it. So,
well, it's fascinating. And what I think it translates into, what you just touched on, Dr. Park, is access to information for the patient and the provider, and a more positive experience. I think it's important to draw a line. If you look back 10 years ago, what the experience was for a patient when coming in to have one of these biopsies, even the recovery that was related and necessary for that small procedure, technology like Karius is helping to improve that experience and that access just leaps and bounds. It's only been a short period of time, relatively.
Yeah. I mean, those procedures are not benign. Even some people think, oh, it's just a little cut and even a needle, whatever, biopsy or such. But those all require, recovery from the procedure, anesthesia for sometimes, and so many other things. And, versus a blood draw, which is what most patients are going to have to succumb to be able to get even just the basic laboratories, right? A complete blood cell count. So yeah, it's pretty amazing that we were able to do this from a blood test.
Yeah, it is. It's incredible. I can't wait to see where we go from here. Both of you have talked about, where we've come from over a short period of time. Dr. Parker, I'd like to start with you. Where do you see us going in the next 10 years? If we're all on this journey together, look out into the horizon and kind of tell us what you see coming next.
There's so many possibilities. I think it's hard to say exactly this or that, to be honest. I think for the individual patient, it's obvious, there's so many benefits from this test, and that for improving medical care, and having timely medical care. So many of our diagnostics, they're non-specific in what they identify. If you think about serology antibody tests, right? They're frustrating because oftentimes you don't need just one, but you need two, a second follow-up at least a week or 2 weeks later, to really then interpret what's going on with the patient. And then the test is taking so long to come back, and we're already addressing that, right? So having a test like this as we move forward in the future to be able to, get a jump on diagnostics diagnostics on management for the individual patient. And then if you apply it to the greater community health, the public health, I've had a long career in public health. And so the first thing that leaped out to me, honestly, when I first, came upon the Karius test was the huge potential for disease surveillance, to support early situational awareness, to be able to address, potential disease outbreaks that could be occurring or emerging diseases. Monkeypox is a great example of one, to be able to try and help in the efforts to control, the spread of that disease, and to help hopefully also in the future advise clinicians and patients on how to, at what point does the patient, is the patient still infectious, not infectious? That question of when is it safe to move around? When are they considered safe and not infectious? When are they out of the woods, as Sivan commented, in terms of their illness? I mean, there's so many questions, right, on the patient journey that you're asking, and to be able to help answer some of that. And then to think about, is this a test that at some point, right now we're focused on the US market, but what if this is a test that could be available for other countries, especially those countries where healthcare access, they don't even have access to the diagnostics that we enjoy here in the US, the basic diagnostics that we were, just talking about and saying that they're really old and, non-specific. There are countries out there that would really die for, basically, literally, for access to even what we already have, and let alone the Karius test. So it's something that, I see as a clinician and someone public health minded to think, global health wise, how do we improve healthcare access, and healthcare treatment in all places around the globe? Because frankly, emerging pathogens are not coming from within the US, they're coming from all over. We travel instantaneously now. So disease travels instantaneously. So it's to our benefit to at our advantage to really think about how can we have something like this, a diagnostic that could be applied globally, to improve healthcare globally. So kind of that's kind of how I'm thinking, but it's just tip of the iceberg, and Sivan, I'm sure, has even more.
Yeah. I mean, Sivan, when I think of all of the data that's going to be coming from, we're casting a wider net, like Dr. Park said. There's so much more data now. We're going to have to lean on, machine learning and artificial intelligence to start sorting through this at a quicker rate, making connections, and then providing that clinical context that Dr. Park mentioned. Also, in your opinion, where do you see machine learning and artificial intelligence continuing to provide value and benefit and impact in healthcare over the next few years and beyond?
Yeah, so I'm going to answer this question. I'm going to tap into some of the things that Sarah mentioned, but I'm just going to say this. One thing that is more fun from talking about the future is to actually make that future happen. So let me walk you through this database machine learning elements that are part of our current state, and as well as part of our future plans. You mentioned the value of data. When Karius first compiled together all these technologies that we need to put in place in order to make this technology a reality, one of the elements was the database. You have to have a good map of all the microbes that exist out there so that you can detect them. If you don't have a description of how a microbe looks at the molecular level, you can't say that you can detect it. So the first version of the technology only had 100 microbes. We never launched the thing. But then over time, we expanded that database of well-curated microbial genomes. And today we can report on more than 1,500 different microbes. This is not because we changed something in the chemistry. We've been given this wonderful analyte, microbial cell-free DNA, and we've optimized a chemistry that allows us to pick up even the smallest fragment of microbial cell-free DNA. And then we had a series of innovations on the analytics side, on the data and machine learning part. And that core component is the data. If you don't have the map, you don't have the right map, you can't plug it in, it's not going to work. And we saw that happening here in monkeypox. There was the outbreak strain. We actually had back in 2019 a monkeypox genome reference, but it wasn't the outbreak strain. That old 2019 technology was actually already useful. We've detected, and Sarah can speak to this quite well. We have detected cases of monkeypox within this technology. But naturally, if you have a better version of these genomic reference, if you update the database, your accuracy just improves. So putting together a machinery that continuously brings in these new insights of what are the genomes that are out there, what's their latest quote unquote version, actually makes a better technology. The second element that we are already seeing in our technology comes around this notion of interpretation of the signal. So Sarah mentioned, well, this patient has this microbe, this other patient has the same microbes. Can we interpret the amounts, the concentration, and conclude that it's actually very important to treat this one and it's okay for that one? The interpretation of the signal is key. The chemistry gave us a wide lens into biology. And now machine learning is tasked with making sense of all that complexity. And all the metadata that we're getting with each and every patient actually allows us to refine our understanding around how to interpret that signal. And that goes into making sense as it relates to treatment, and making sense as it relates to diagnostics, and making sense as it relates to prognosis. This notion of connected medicine has been around for a while outside of infectious diseases, where you're trying to put like these tumor balls or communities around the study of any particular disease. We absolutely envision a future in which we can bring related cases together so that we can interpret them and that we can drive the right treatment. In the Karius system, when we sit here next to our servers and look at the data, you see cases popping up all over the country. And at the molecular level, it seems to be connected. It's a rare microbe. It doesn't happen, very often. And all of a sudden, we see several of these cases. I have absolutely no doubt that the chances that these physicians treating these patients have no clue about these other cases. It takes time for them to learn about it. There might be other mechanisms, but Karius is sitting on that lifeline of data that we have full intention to actually make it accessible one way or another to aid with the interpretation of the test. Now, there's another important component I should mention, because if we just talk about machine learning and AI and data, we're going to miss out on a very important component. Today, Karius operates as a central lab. We are receiving samples 6 days a week from all these different hospitals all over the country. And then we receive a sample here, 8:30 in the morning. You might see a truck coming behind me, a FedEx truck dropping these kits. And then 26 hours later, we return these results back to the physicians. It only makes sense that there's a future in which such technologies will be closer to the physician and ultimately closer to the patient. You just need to be there. So as I expand the thinking beyond just the data and the machine learning and the cloud into the realities of infectious disease diagnostics, and you're talking about 10 years into the future, I have no doubt that the component in that strategy has to do with getting closer to the physician, getting closer to the patient. And the last thing I'm going to say, as it relates to both of these notions, data and this notion of chemistry and getting closer to the patient, and we already see that elsewhere in medicine, is this notion of integrated diagnostics, meaning that you're not just treating one disease in the patient, you're really tracking the patient and you're trying to take care of the patient. So today, Karius delivers an infectious disease diagnostic tool. This is being integrated with imaging data and other tests related to comorbidities in that patient, and all of this needs to come together in the physician's head as they decide on the next step. I can imagine in that future of data and machine learning a better, more integrated diagnostics, a more connected medicine that doesn't just include many instances of the same disease, but include many elements in the disease of that single patient. So treating the patient rather than the disease.
I love it. You talked about getting closer to the provider and closer to the patient. When I think of some of the best innovations, the most disruptive technologies over the past few years, it's been those that have empowered providers and empowered patients to manage their own care in some way, or at least have more control and more access to manage their own care. And so that leads me to my next question. This is for either of you. With so much innovation going on and access to all different kinds of technologies being made more readily available to providers, to doctors, how important is educating those doctors and those providers on the new solutions, the new options that they have at their fingertips, like the Karius test? How important is it for you guys to get in front of those doctors and those physicians and teach them about what's possible through Karius?
Yeah, it's a huge priority. I'm grateful to be able to have this opportunity that I have to be working for Karius and therefore have, such close proximity to experts in the field and to be able to dialogue and learn amazing amounts. I've talked with my colleagues about the fact that I feel like I'm in an Uber ID fellowship, subspecialty training. And, then I talk to colleagues and I'm trying to let them know as well. But, that's informal. But then we have formal efforts that we're going through, trying to put out educational programs. And, we're talking about putting together some podcasts ourselves that provide some more sort of educational bite-size education videos, if you will, to be able to get the word out about the technology, the capacity of it, the capabilities of it, the potentials down the road, to invite discussion, all those things, discussing with
Sure.
professional societies to try and see, we do sponsor communications talks, lectures, not by us necessarily, but by other clinicians who are familiar with the test, who can then relay their, hands-on experience and that patient journey directly. That's much more meaningful, frankly, when you're talking to a fellow clinician, right? Education, I think, is absolutely paramount. And then, of course, there's our website that our folks in the Karius team that work on to try and educate not just the clinicians, but just, anyone who might fall on the website and want a simple understanding of what is this test so they can discuss it with their doctor, So all these things are really important because otherwise being cooped up, like our own little pandemic and closed off from the world. I mean, it's like, then it is like the pandemic. We're shut down and we don't get to, we don't move forward together with the rest of the world and move forward in patient care and having an impact. So the only way to have that impact is through education.
And I think we're touching a very important point here, which is that of diagnostic stewardship. Karius has a very strong commitment to make sure that we're putting together the material, such as the ones that Sarah mentioned, that will educate our partners on where we think this technology is most useful today. David, we spent a ton of energy optimizing this technology to make sure that we provide the best possible service for the immunocompromised patient. It means that we have to tweak a lot of these parameters to make sure that we are delivering best care options or best diagnostic options for the physicians treating those who are immunocompromised, the cancer patients or the transplant patients, usually when they are acutely ill. So that means that the technology as it is today is not for the sneezing kid or the worried well that attempts to test other things that they have in mind that might have gotten. I definitely see a future in which such a technology gets optimized for each one of these use cases, but this is not just, like using salt, put it on everything. You have to remember that this technology was optimized for particular use cases, and we are putting together all the materials, many of which are published in peer-reviewed journals or abstracts that we're presenting. ID Week is just around the corner. I'm sure that many of the physicians that are leveraging the Karius test or considering leveraging the Karius test will head over there and see the publications or related mentions. And this notion of diagnostic stewardship is a top priority for Karius, and we're working really, really hard to make sure that it's being applied in areas where we believe it has the biggest value.
Well, what a great mission to provide support for those that are most vulnerable. And Dr. Park, you mentioned your website. I'll drop it here because I think it's that important. There's some great stories, great testimonials there from patients, and it's KariusDX.com. And I encourage everybody to go out and take a look and at least watch those videos and learn a little bit more about the impact that's being made. Before we go, and I know I've kept you longer than I expected, but before we go, Sivan, I'll start with you and then I'll throw it over to you, Dr. Park. If there was one thing that you could leave our listeners with, if they walked away with just one thing, what would you want that to be from this podcast? Sivan, we'll start with you.
Yeah, I think I hope that this will resonate here with the audience, but I think at the core of where Karius started is this notion that it's simply unacceptable to live in a world in which patients are still dying from undiagnosed infectious disease. And the reality that there are some technologies out there, and Karius is among these companies that is working really hard to provide new options. The fact that it's there is kind of a signal that there are some technologies that we need to think very carefully about how to bring into the right use cases. So hopefully this will resonate with your audience as well. I know that it's at the heart what we do here at Karius.
Dr. Park?
The big thing that, kind of the thread that has been running through what I've been commenting on is that this is a diagnostic test with a humongous potential, but that potential is only realized when you have the patient and the doctor along for the journey. So it's a journey that we're going on together, and to realize, the amazing potential, that further potential that could be realized down the road. And that's what I'd like people to realize, to take home about this test, I think.
Well, it's going to take a village. The patient, the provider are definitely part of that village. Innovators, disruptors like you guys at Karius are a big part of that village too. So thank you for everything that you do. Thank you for being on Highway to Health. And I've learned a lot today. Hopefully our listeners have as well. I'm sure they have. Good luck to Karius, and I can't wait to see some of the exciting things that you guys have coming forward.
Thanks for having us.
Thank y'all.